When we have equivalency, you can replace one piece with another equal piece, or essentially we can replace like for like. So for example, if I have a plus b is equal to 2 minus x, I can replace this a plus b with an equivalent 2 minus x. So my new equation then becomes, or my new expression is going to become, so like for like replacement, that a plus b gets replaced by 2 minus x. And by doing so, we end up with an equation with one variable. So this technically, we could solve this. If I have something that looks like this, I want to replace like for like. So I know that 2x minus a equals 7. Well, I'm going to do this. I'm going to rearrange this and say 2x minus 7 is the same as a. And since I have an a in here, I can do a like for like switch. So I can switch out this a for a 2x minus 7. So it looks like this. 2 times a plus 5 equals 3x plus 1. That a can be replaced by a 2x minus 7. And this is still an equation that's balanced still. And we went from a system of two variables and two equations to one variable in one equation, which then could be solved. So here we can take a look at this one. If we can find an equivalency, we can replace like for like. In this one here, I'm going to maybe solve for that 3a. So I'm going to say 3a is equivalent to 6b's plus 9 1's minus 3 x's. And by doing so, I can replace this 3a. It doesn't have to be an a. I can actually replace that whole 3a with this whole equivalent. I can divide by 3 to cancel some things out, but it's easy enough to just keep it as a 3a. And by doing so, I'm going to do a like for like replacement. So 2x minus 3a equals 12. And this is going to be replaced by 6b plus 9 minus 3x. I did a like for like replacement. Now in this case, although I did a like for like replacement, I still have too many variables and this is not solvable. So the main idea is we can do a like for like replacement anytime we want. The goal though is we want to substitute a variable to eliminate one of the variables in the system. So like we did in this example here, we're able to only have one variable. Same with the first one, we were able to reduce it to one variable. So this is now the next layer. Then we want to try to eliminate one of the variables. Here we just did a like for like substitution. We're going to do a like for like substitution here to eliminate one of the variables. So what I can say is that this y is equal to 3x squared minus 10. I'm going to replace that y with the exact same expression. So I'm going to replace the y with the 3x squared minus 10. And if I keep it equal to negative 2x squared plus 35, I've done a like for like replacement. This is still balanced. That's the only rule I need to follow. I can try to solve this. So I'm going to add 2x squared to both sides. So I get 5x squared minus 10. I can solve this by isolating x. So I'm going to add 10 to both sides. Divide both sides by 5. I end up with 9. And solving for x, since I'm undoing squares, I have to have a plus minus. Now, this is a system. So there's a system in x and y, so once I solve for x, I still have to solve for y. So I'm going to have a set of solutions here. So x is equal to 3. The y value, when I substitute 3 into this equation, and it doesn't matter which one, I end up with, I'm going to do it to this one here so I don't have that negative 2x squared. So I'm going to substitute 3 in here. So 3 squared is 9, times 3 is 27, minus 10 is 17. So there is one solution pair. I can plug in negative 3 into the same thing, and I end up with the same y equals 17. So I have my second solution. And when I actually graph this, if I sketch this graph, this is a parabola that kind of looks like this, and it's another parabola that looks kind of like that. It's going to be, maybe I'll draw it a little bit more accurately. It's going to be a really tall parabola, and this is going to be a really wide, it's going to be a little bit wider parabola. And I'm going to have solutions here at 3, 17, and negative 3 and 17. So it's going to be an upside down parabola with a right side up parabola, and they will intersect in those points there.